All right, I've got an introduction to make here. This is our first speaker. This is Everett Ediger. I want to say it right. And he is from La Junta High School. And just to give a little bit more about him, he normally has a partner who does this project with him. So he's being brave and doing it all alone. Her name is Zoey Matinez, but they got to go to
Montoya.
I said Martinez. I'm sorry, I got the wrong name. They got to go to State Science Fair and compete there, where they did very well. And then they also got to move on to International Science Fair. And he's going to talk about a project that he did that very much relates to this place. So, welcome, Everett.
So, as Warren said, I'm Everett, and I'm going to be a senior next year at the high school here. And so, I guess just to start with, I'll talk about sort of my inspiration for the project. So, there was a researcher from the University of Eastern Michigan who came down to the area, and so he works in a lab that does research on tarantulas. And so, if you guys are unaware, there's a tarantula migration that comes through the area during the fall time. And so the problem with that is that there's only 11 published papers on the tarantulas in the area. And so obviously that isn't a whole lot of known knowledge. And so there's sort of a need to gain more knowledge on this, especially given the fact that they're somewhat important if there's a giant migration that just comes through the area every single year, right? And so he came down and he came to my classroom and actually talked about his project and how he was going about the doing it. And then my partner and I sort of we sort of caught interest with it, and so we wanted to sort of piggyback on what he was doing and do our own thing with it. So he's writing a master's thesis on them. I was doing a science fair project, so there's a little less, it's a little less complex in some ways, but, and his was focusing on a little bit of different things. But I guess to start with sort of the important regional aspects of it, when he came down here, one of his main focuses was the idea that science tends to be the sort of thing where researchers will come into an area and they will, try and make the claim that they know more about a tarantula or, a given thing in an area that they're doing research on. And so he started his project before he even set ground on the grasslands where the tarantulas are actually at. He wanted to get a baseline of what the community knew about them. So he went around to community members and actually asked them, what do you know about the tarantulas? His research actually more so pertained to specifically the timing on their mating season, because we don't know the exact range there. We know roughly, it's fall time, but we don't know a whole lot more than that. And so he was trying to get a better sense of how temperature maybe affects that. And so he went around to community members and actually asked them, what do you know? Before he even did anything with the tarantulas themselves. And then after he got that sort of baseline down, he then went out into the grasslands and actually started performing his research, where he was able to get more numbers and such. But he started with the community. And so obviously, it also sparked some interest in some high schoolers as we took this into our own project, where we were specifically looking at how soil qualities affect where they will make their burrows. So, as I said, not much is known, so we don't really know much about their, the conditions of their burrows or anything like that. But if we know conditions on the soil that they're making their burrows in, we can eventually get to a point where we can understand more conditions about their burrows themselves. And I guess just to get into the project itself, because it's kind of interesting. So our question in the top left there and right in the center here. So we were looking at how soil qualities affect where Aphonophelma hansi, the scientific name for the tarantulas, will affect where they make their burrows out in the grasslands. And so we had tested 4 main qualities there. pH, water content, density, and then the composition of the soil. And I won't get into how we established all of those things, but you can sort of guess with pH, it was pretty easy. You just name standard normal pH test strips, and then we would reference the scale as, if you can see it here, the normal 1 through 14 scale, and referencing from there. But sort of getting into the specifics of what we found as to how it pertains to the region. So pH, we established that. So in the most top left graph here, there's so we had collected our data across 3 big plots, and it was actually the same plots that Dallas was the name of the researcher who is writing a master's thesis on these guys, but we used the same 3 plots so that he could maybe use some of our research as well if he wanted to get a better ground level understanding of them. And so we had plotted here on the pH scale where they all where the dirt samples all sort of lied. And as you can see, they're all sort of bunched together, and so we weren't able to get a whole lot from that. And then these top right graphs, these are the density graphs, and there isn't a whole lot to look at here. If you look at this middle one here, so on so there's 2 bars, and the left bar on each of the sets there is the density, the average density across all of the samples that we collected. And those were all relatively the same, but there was a large variance in the amount of burrows, and that was actually another big inspiration for our project. So on one of the plots that we did our project on, there was an average of I believe 13.8 or 13.2 burrows per 50 by 50 meter section, which is a lot when you think about our other samples that we took, where there was an average of 0.8 burrows on every 50 by 50 meter plot. So there's a big difference there, but there isn't a huge difference in the density that the dirt displayed there. And so we weren't able to get much from there. And then it gets a little bit more interesting when you look at the water content. So we were able to establish that there's some correlation there, but it didn't appear that individual plots provided a correlation, but maybe across a larger plot there is a correlation. And so we were able to identify that across the bigger plots there's things that might affect the water content levels. And so that's things like on one of the samples there was cows that would graze on the area, and so they're doing their business there, and so that's going to affect the salts and those sort of things that are in the soil itself, while other ones were pretty desolate of any sort of vegetation or animals grazing on them. So that would affect the sort of things that would affect water content. But then it gets really interesting with these bottom graphs that display the composition of the soil. So we did it as a simple test where we established basically the particle size on across each of the samples, and so that got us the breakdown of the sand, silt, and clay. So that's biggest to smallest particle size. And so we were able to figure out that, unsurprisingly, there's a lot of sand out in the grasslands, but when you get to the breakdown of the silt and clay, there's a big difference in how those trace amounts of silt and clay play into it. So we were able to establish that tarantula is preferred when of the remaining percentage of silt and clay, if there was more silt, they would burrow there more often than if there was more clay. We aren't able to really identify why that is because, as I said, we don't really know a whole lot about them, but you can sort of infer that they're kind of small, and it's sort of interesting little tidbits about tarantulas as I'm talking here because they're really cool. They actually don't have very many muscle groups, and so their way of moving around is actually called hemolymph, and it's basically they push water in and out of their limbs, so they basically move on hydraulics. And so this obviously poses, when you look at Dallas's research where he was looking at how temperature affects when their migration would start, that if it's below freezing, they obviously die because then they basically just turn into an ice cube, right? So, and then obviously too hot poses the opposite, the opposite problem that you probably don't want either. And so we're able to infer from that they probably aren't going to be able to dig too much from, if the sand is super clay filled, it's going to be a lot harder to dig through, and so they're not going to be able to do much there. Yeah.
Fabulous.
Open it up for questions.
Yeah.
You talked about how there were more tarantulas where there were cows.
Yeah.
Okay. What is the predator of tarantulas?
Part of that answer is we don't know, because we don't know a whole lot about them. But we do know things like tarantula hawks. I don't know if you guys have seen those, but they're actually kind of big insects that they're black and have orange wings, and they fly around, and they actually work on a very interesting mechanism where they will they use their venom to actually paralyze the tarantulas. They don't actually outright kill it, and then they'll lay their eggs on the tarantula, where then the young feed on the actually still live tarantula that's just paralyzed.
My thought process was, along with moisture, could the cows also be deterring predators, making it a preferential burrow area?
Yeah, that easily could be the case. So on top of that, that area that I was referencing with a lot of cows, there's actually a lot of cholla, the sort of long spindly cactus, and something about that, just by observation, we didn't actually get a real good count on this, but by observation, the burrows actually tended to be kind of close to those cholla, and so it seemed that maybe that on top of it might also, that would also be a predator deterrent if you're looking for a place to hide. You're going to want to be underneath something that's spiky, probably. Yeah.
So, where are the tarantulas migrating from, and where are they going to, and how long is that migration?
Yeah, so migration is actually a bit of a deceiving term. It's actually their mating season. And so if you, and actually while I'm at it, I might as well encourage you all to come to the Tarantula Festival that we'll be holding actually here on September 29th and 30th. But so it's during the mating season, and part of what we do there is you can actually go out and find tarantulas, and you'll actually go with people like Warren, and you'll actually be able to find tarantulas, look at them, sort of observe them on your own. So the answer to your question, it's actually their mating season, and if you actually go out during the day looking for tarantulas, there's almost no chance you will find their females. So it's actually the males that are moving around. And we don't know a whole lot about how they move, but we, at Dallas, in sort of his findings, he thought that there's a pretty big chance that their movement is actually a giant left-handed spiral. They actually will slowly start moving inward. And sort of other interesting tidbits about tarantulas is the males live, we think, about 3 to 4 years. The females can live upwards of 30 or 40 years. So there's a big difference there. And and so part of that is the males actually will walk themselves to death. They just keep walking and walking. Exactly. They keep going until they find a mate, and if they don't, they just keep walking. Yes.
I think I may have missed this. How are you able to find the tarantula burrows? Like, obviously we see them moving, but how do you know where the burrows are?
Yeah, so this was actually more so something that Dallas had established, but we used as well. He had this checklist where it was ways that you could prove that a tarantula was actually living in it, and so you had to do it somewhat by comparison. So there was, obviously you can't take any random hole as a burrow, but if you look at, for example, there's wolf spider burrows that are also out in the grasslands, and there's a pretty big difference between the two burrows there. So a wolf spider burrow tends to have, they'll use their webbing to make sticks. They'll sort of make what almost looks like a nest on the outside, but a tarantula will lay sort of a layer of silk on top of their burrow. So that's one way you can tell.
I
Yes.
got a great picture of one yesterday, and you can see the tarantula down in it. I'll pass that around while he's talking.
Yeah, and we can sort of use that for reference. So I believe in this picture it is a male. So you can sort of see that the difference, I can sort of describe the difference, of the males and females here. So the males are smaller, and in the way of they're actually a little less hairy than the females, and their coloration is a little different. They'll be a little bit darker than the female. So if you want to imagine what a female looks like, imagine that, slightly bigger, a little hairier, and a lot lighter in color.
How big are those holes?
The holes themselves are, thereabouts. Yeah, they're not super big. No, the tarantulas are probably about up to your first knuckle. Yes.
This part of the world's been in a drought for numerous years.
Yeah.
This is an unusual spring for us. Do you anticipate seeing any different, more or less, like in certain parts of the world, like
It's hard to say. Yeah, it's hard to say. I mean, this specific tarantula, the region in which they actually live is much bigger than just just this corner of Colorado. They actually extend all the way from Texas to Missouri to, Oklahoma. They sort of live all up in there. So there isn't, drought doesn't appear to necessarily be a, driving factor, obviously, where they go. But they live in places where it isn't drought-filled as well.
Is the common name of the one you're testing the Texas brown?
Yeah, Texas brown or Oklahoma or Missouri. But I am pushing for the Colorado brown.
I agree. I
Yeah,
had the Texas brown
exactly.
yesterday, and I told
Yeah.
everybody the same thing.
Yes.
The females stay in the burrow while the female is
Largely, yeah. So if you go at the right time of night, you can actually find more females are out on the surface. The issue with that is they actually don't have a very good spatial memory, and so they can only get about a dinner plate's they have about a dinner plate's worth of memory. So if they get outside of that, they're completely lost. So they tend to make new burrows after that point.
Can you see it with a certain type of light?
You just sort of have to be paying attention. I mean, if you can. Sort of other fun side note, if you go out during the nighttime and you have like a headlamp, you can actually find wolf spiders very easily that way because they have eyes that stick straight forward, and so their eyes are actually reflective such that you see the light bouncing off of their eyes and ears. But tarantulas don't. Their eye pattern is not like that. So it's a little, but they're also bigger, so they're easier to spot in that sense. Yes.
Can you see tarantulas with UV light?
I'm not sure any research has been done on that.
I don't know if anybody's tried it.
Yeah, I don't think anyone's tried it. Yeah, other critters do.
I have tried it. The answer is no.
Okay.
Scorpions, yes. Tarantulas, no.
Yes. Well, yes.
Do we have any idea of how human activity in the area has impacted migration?
We don't. Once again, they haven't been very well researched, so we haven't been able to dig into those sort of deeper questions about maybe how humans have impacted them. But I mean, we did one of the samples, as I said, cows are grazing on there, and that wasn't. It's not like cows happened to stumble on that area. That was human impact. So, I mean, you can sort of infer that there is definitely something, indirectly with agriculture. There's probably something going on there.
Science teacher, I appreciate the use of the term infer appropriately.
Yes.
Thank you.
Nice job.
Yeah.
We probably have time for another question or two, but then we need to wrap this up so we can move into the afternoon sessions. Are there any others?
How did you do at Nationals?
We didn't get any awards at the International Fair. But at state, we did very well. There are surprisingly few awards that are given out for this sort of biology. So you'll find at these sort of things a lot of the awards are very specific, and ours did not necessarily apply to that because
category that they were looking.
Exactly, because we're invertebrates, and most of the judges at both the state and international fair. The most common question is, are you afraid of spiders? Not necessarily anything that dug into the project a little deeper. So there was sort of that. There was a little bit of a block there as well. But
People don't like them enough.
yes, exactly. That is definitely an issue.
Yeah, thank you for your sharing your research.
Yeah.
What has this led you to think about going into the future, maybe a major or any kind of studies for this?
Yeah, I would definitely consider entomology as a field of study. I know that through Dallas, he has sort of a lot of what he talks about is the idea that invertebrates. If you look at the ratio of papers published on vertebrates versus invertebrates, there's a very stark difference there, and so it would be worth going into a field like entomology where I'd be studying more on things like invertebrates that are. Things like tarantulas that not many people care about. So.
Thank you.
Yeah.